NCM Learning Center. Good morning friends. In this video, we are going to discuss a concept how to find whether current lags the voltage or leads the voltage. That means inductive power factor or capacitive power factor. The outline of the topics are, first we will discuss a basic concepts. How to find whether current lags the voltage or leads the voltage. Then we will solve a previous year exam questions from TNPSC Company Engineering Service Examinations and TNPSC Municipality and Water Supply Board exam questions. Then TRB Teachers Recruitment Board exam questions from the topic. Finally, do it yourself. I will list the questions. You go to solve the questions. Okay. This is the outline of the topics. Okay. First, the basic concepts. We know that inductor opposes the rate of change of current. Voltage across the inductor VL is equal to L into dA by dt. It means that the inductor restricts the change of current. So, in inductor, current lags the voltage. Okay. In the Phasor diagram, we represents if current is a reference, I angle 0, voltage will be lead. Current lag, voltage lead. Okay. Current lags the voltage or voltage leads the current. Both are same. Okay. Here voltage leads, current lags. Okay. Otherwise, in another representation, here voltage is taken as reference. So current will be lag, minus 90. Okay. Okay. Next point. If angle between the voltage and current is positive, then power factor will be lagging. Remember the point. If angle between the voltage and current is positive, means power factor is lagging. How is that? Let us take for pure inductor, here voltage V angle 90 degree. If you take V angle 90 degree means what will be the current value? Current value is equal to I angle 0 degree. If you ask the pure inductor, current lags the voltage by angle of 90 degree. Okay. So here the voltage angle is 90, current angle is 0. So the angle between the voltage and current, 90 minus 0, so 90 positive. For pure inductor, angle between the voltage and current is 90 positive, so lagging power factor. Remember the point, if angle between the voltage and current is positive means power factor is lagging. Or if angle between the voltage and current is negative means power factor is leading. Okay. Next, third point, if voltage V is equal to Vm cos omega t plus pi 1 and current I is equal to Im cos omega t plus pi 2, the phase angle of voltage V is equal to pi 1, phase angle of current I is equal to pi 2. Okay. So the power factor angle is the difference between the angle of voltage and current. So pi is equal to pi 1 minus pi 2. This is the power factor angle. If power factor angle is positive, then the power factor will be lagging. Okay. Power factor is equal to cos pi. We know that. Next, for capacitor, it opposes the rate of change of voltage. So it restricts the change in voltage. So in capacitor, voltage lags the current. That means current leads the voltage. Both are same. So we may represent in the phase angle form, voltage lags. If you consider voltage as a reference, current will be leads, 90 degree leads for pure capacitors. In another way, if the phase angle of voltage is 90 degree, the current will be 180 degree phase angle. 90 degree leads. Current leads the phase angle by 90 degree for capacitors. Okay. The same concepts, if the angle between the voltage and current is negative, then the power factor will be leading. For example, let us take pure capacitor. The phase angle voltage is reference. Then it means current will be 90 degree leads. Okay. So the angle between the voltage and current is 0 minus 90. Angle of voltage is 0 degree, angle of current is 90 degree. Minus 90 degree. So for pure capacitors, angle between the voltage and current is minus 90, negative. It means this leading power factor. Okay. If power factor angle pi is negative means power factor is leading. If power factor angle pi is positive means power factor will be lagging. Okay. Here leading power factor means current leads the voltage. Lagging power factor means current lags the voltage. Okay. Next points. If inductive reactance XL is greater than capacitive reactance, here inductive effect is higher. So lagging power factor. Inductive effect is higher means lagging power factor. Another point, in RLC circuits, we know that impedance Z is equal to R plus J XL minus XC. If XL is greater, If XL is greater means XL minus XC is positive. If XL minus XC is positive means the power factor will be lagging. Inductive nature. Inductive effect is higher. So power factor will be lagging. Opposite side. If capacitive reactance is higher than the inductive reactance means, so capacitive effect is higher. That means leading power factor. For that case, XL minus XC is negative. Okay. Next point, power factor calculations. We know that power factor is equal to cos phi. If you know the base angle difference between the voltage and the current, directly we can calculate power factor. If you know the impedance, how to find the power factor? We know the impedance triangle here. This is the resistance, this is the reactance, this is impedance. This is the power factor angle. So cos phi is equal to R by Z. This is the power factor. Okay, if you know the impedance Z and R, we can calculate power factor. Okay. Next, power triangle. If you know the real power and reactive power, how to calculate the power factor? This is the power triangle. Here, this is a real power. P is a real power or true power or active power. Okay. Q means reactive power. S means apparent power or complex power. Pi means power factor angle. So from that power factor, cos phi is equal to real power by apparent power. Okay, if you know this power, real and reactive power, we can find the power factor. Here, apparent power S is equal to root of P square plus Q square. Here, Z is equal to root of R square plus XL square. Okay, this is the concepts. Now we will solve the questions from the previous year examinations. The first questions. This questions from TNPSC Combined Engineering Service Examinations 2022. In these questions, V1 is given 30 sin omega t plus 10. V2 is given. We have to find which of the statement is true. Okay. Whether V1 leads V2 or V2 leads V1 or V1 or V2 are in phase. We got to find. So represents this equation in a phase angle diagram. So here V1 is given 30 sin omega t plus 10 degree. Here x-axis is a cos, y-axis is sin. Sin should be in decreasing. Okay, this is cos, this is sin. Here plus 10. Sin value is given. So plus 10. So here this is a V1. 10 degree lead from the imaginary axis. Negative imaginary axis. Okay. Or other words, we can write. We know that cos of theta minus 90 is equal to sin theta. Cos of theta minus 90 is equal to sin theta. We got to convert this sin into cos. Cos of theta minus 90 is equal to sin theta. Okay. Cos theta minus 90 is equal to sin theta. You will get this. Okay. Now, simplify these equations. We will get this. Both are same. So here pi 1 is minus 80. So V1 should be lag of 80 degree from reference. This is 80 degree. Okay, both the representations are same. So you may represent in cos or you may represent in a sin. Okay. Next, represents V2. V2 is equal to 20 sin omega t plus 50. So from negative imaginary axis, 50 degree lead. 50 degree lead. This is 50 degree lead. Directly you may represents. Or other words, we got to convert the sin into cos. Cos of theta minus 90 is equal to sin theta. Okay. Now simplify this equation, we'll get this. From cos axis, 40 degree lag. So 40 degree lag. Okay. Now observe V1 and V2. Here V2 leads V1. V2 leads V1 by 40 degree. So option B is correct. Okay. Next, second questions from TRB, Teachers Recruitment Board 2021. Okay. Objective of the question is we got to find the current and voltage phasor representation for the circuits. The circuit have only capacitor. So we know that In capacitor, current leads the voltage. Okay. Now check the options one by one. And option A, B, voltage B is in 90 degree, but the current I is in 180 degree. So current leads the voltage. So option A may be correct. Now check option B. Here current is in 0 degree, but voltage is 90 leads. Voltage leads the current. But in the capacitor, current leads the voltage. So option B is wrong. Option C. Here current is in 90 degree, voltage is in 180 degree. It means that voltage leads the current by 90 degree. Option C is wrong. Option D. Here voltage is 0 degree, but current is minus 90. Lags. Current lags the voltage. Option D also wrong. Option A is correct. Because in the option A, base representation only tells current leads the voltage. In the capacitor, current leads the voltage. So option A is correct. Okay. Next, third questions. This question is from TNPSC Combined Engineering Series Examinations 2024. Okay. Here real power is given, reactive power is given. We are going to find power factor. The inductive load is given. Inductive is given. Okay. From that we can conclude inductive means lagging power factor. So option B and D is wrong. Option may be option A or C. Okay. We know the power triangle is the real power. P is the real power, reactive power. Q is the reactive power. S is the apparent power or complex power. Okay. So from that power factor cos phi is equal to real power by complex power. So here real power and reactive power is given. We got to find the complex power S. S equal to root of P square plus Q square. Okay. Now P and Q value is known. Substitute here. Simply this equation will get cos phi is equal to 0.768. Power factor is 0.768. So option C is correct. Okay. Next, fourth question. This question is from TNPSC Tamil Nadu Municipality Water Supply Board Examinations 2024. Here impedance is given. We have to find power factor. Okay. So Z value, impedance value 3 plus J4. This is XL minus XC. This is R. XL minus XC is positive. If XL minus XC is positive means inductive load, lagging power factor. Okay. So option D is wrong. Because it's given as leading. Okay. If XL minus X is negative means capacitive. Here XL minus X is plus 4 positive. So inductive. Okay. Next, we know that impedance triangle. Based on the impedance triangle, power factor cos phi is equal to R by Z. Z value. Here R value, XL value is known. So from that we can find Z. Z is equal to root of R square plus XL square. So value is 5. Power factor cos phi is equal to R by Z. R value 3, Z value 5. Substitute here. We can get the answer as 0.6. 0.6 lagging power factor. So option B is correct. Okay. Next, fifth question. Final questions. This question is from TNPSC Tamil Nadu Municipality Water Supply Board Examinations 2024. Okay. Here we got to find whether current lags the voltage or leads the voltage. The condition is given. From the condition we can find. Okay. XL and XC value is given. Okay. Here we may rewrite this equation. L omega to 1 by omega c. We know that XL is equal to omega L, XC is equal to 1 by omega c. So replace this omega L by XL value. Replace the 1 by omega c value by XC. Because XL is equal to J omega L, XC is equal to 1 by J omega c. Okay. Manual to form. Inductive reactance is XL is equal to omega L. Manual to form. Capacitive reactance X is equal to 1 by omega c. Okay. Now here XC is higher than inductive reactance. Capacitive reactance is higher than inductive reactance. So XL minus XC is negative. Because XC is higher. XC higher means XL minus XC is negative. XL minus XC is negative means capacitive effect. Capacitive nature. Capacitive effect means current leads the voltage. So option B is correct. Okay, good. Next, do it yourself. Only one question is listed. This question is from GATE 2014 instrumentation exam questions. Try to solve these questions. Okay. Just pause these videos and try to solve these questions and comment your answers. If you have any doubts related to the discussions, kindly post your doubts in your WhatsApp group or comment box of these videos. Definitely you can get the clarifications. Continuously watch our channel. Definitely you can get the good knowledge and the good marks in the competitive examinations. Okay, good. Thank you. Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.